Earlier, I said that you might choose to calculate moment of inertia through the center of mass and shift it afterwards. The parallel axis theorem allows you to do this. That when we have an object, we frequently know what its moment of inertia is around the center of mass. That's how we do the calculation. However, you might be rotating around a different point, right? You might just put a hinge somewhere else. So the book has a proof. I'm not going to worry about the proof on this one. But the idea is that you get a new moment of inertia based on the old moment of inertia, where the old one is by definition through the center of mass. And then there's this correction term. The correction term is the mass of the entire object multiplied by the distance from the new axis to the center of mass. And you should note that the units of moment of inertia are always going to be kilograms meters squared. This is also going to be kilograms meters squared, so the units here make sense. So whenever you have the same object rotating in a different place, you can use the parallel axis theorem to actually relate the moment of inertia through the center of mass to a different point. Now, obviously, if you wanted to be all crazy, you could then say, well, what if I have a new point over here that's a different distance entirely? I'll call, instead of d, L. Well, obviously, you can then relate the moment of inertia through this point to that point using this equation as well by then relating L and D and whatnot. So you can be asked to do some more complicated things, but anytime that you're being asked to find the moment of inertia of a shape based on a change, a different place of the rotational axis, you want to use the parallel axis theorem. Now, one thing I want to point out, the word parallel in the title. Notice that these two lines, the axis through the center of mass and the new axis, are parallel to each other. The lines point in the same direction. If I wanted to instead, and it's always hard to show this in 3D, right? This is some sort of oval shape that it looks like these axes might be perpendicular to the direction of the face. Let's say I then wanted something completely different where I take it on its side so that I kind of skewer it. And then say, hey, what if it rotates like that now? This axis is not parallel to these. So I can't use the parallel axis theorem to relate this new moment of inertia to my original one through the center of mass because they're not parallel. So be careful, make sure that you're always relating parallel rotational axes, but then otherwise, it's this pretty simple equation for doing it.